This is lesson 4.2 for Mrs. Cucci's College Now Precalculus. Today we're going to be talking about exponential functions and their graphs. By the end of this lesson, you will be able to graph exponential equations and exponential functions, and you'll be able to solve applied problems involving exponential functions and their graphs. Okay, so an exponential function is a function where x is a real number and the base is greater than 0, a is greater than 0. We call this an exponential function with base of a. It's an exponential function because the variable is in the exponent. So we're going to take a look at the graph of y equals, or f of x equals 2 raised to the x power. Okay, so what we're going to do is we're going to go through and we're going to graph this by hand, and we're going to come up with the values for this function by hand as well. Okay, so just like you did in junior high, what we're going to do is we're going to go through and we're going to create a t-table. Okay, so we've got our x, we've got our 2 to the x, and we have our f of x. Okay, so let's start with when x is equal to 0. So we're going to find f of 0, or 2 to the 0, which we know is 1. Okay, so this would be 2 to the 0. 1, 2 to the 1 is 2. 2 squared is 4. 3, 2 cubed is 8. And we also want some negative values as well. So negative 1 to the negative 1 is 1/2. Negative 2, 2 to the negative 2 is 1/4. And negative 3 to the negative 3 is 1/8. So basically what we've done is we've created a set of points for ourselves. 0, 1, 1, 2, 2, 4, 3, 8, negative 1, 1/2, negative 2, 1/4, and negative 3, 1/8. Okay, and we're going to go through and we're going to plot those. So 0, 1 is right here. 1, 2, 3, 8. So I'm going to be up here. Okay. Negative 1, 1/2. Negative 2, 1/4. Negative 3 is 1/8. It's going to get closer and closer to that x-axis. And let's just sketch this in. And then this is going to get smaller and smaller and smaller and closer and closer and closer to that x-axis. Okay? So we have our function f of x equals 2 to the x power. Okay, so you notice that as x increases, the value of the function increases without bound. It gets bigger and bigger and bigger exponentially. As x decreases, the function gets closer to 0. So as x approaches negative infinity, y approaches 0. But it doesn't actually ever equal 0, because what we have here, and we've talked about this quite a bit in the past, is we have a horizontal asymptote at y equals 0. So this function never actually touches this x-axis. There's no value of x that I can plug in that's going to make this function equal to 0. Okay? Okay, so the next one we're going to look at is f of x equals 1/2 x. And we're going to do the same procedure here. We're going to start by building that table of values. Okay, so let's start by actually taking a look at the function. If you look at the base of this function, this is actually very similar to something that we have just done, right? We just did 2 to the x. Now, if you remember dealing with bases, common bases, I could write this as 2 to the negative 1 of x, which is simply 2 to the negative x when I raise a power to a power, okay? So what I'm able to do here is actually take those points from my original function 2 to the x and adjust the x value. All I've done is taken the x value and made it negative. Okay, so I'm going to kind of throw this by the wayside for now and look at my original points. I had 0, 1, 1, 2, 2, 4, 3, 8, negative 1, 1/2, negative 2, 1/4, and negative 3, 1/8. Now, if I'm using this rule where that x is becoming negative, I can very simply take these and change them. 0, 1 remains, negative 1, 2, negative 2, 4, negative 3, 8, 1, 1/2, 2, 1/4, and 3, 1/8. Okay, so now when I go and I graph that, 0, 1, negative 1, 2, 2, 8, which again is up here, 1, 1/2, 1/4, 1/8. Basically what I've done is I've taken my function and I've reflected it over the y-axis. Okay, when that x value becomes negative, it's a reflection over the y-axis. Okay, so now as x approaches infinity, y now approaches 0. So I still have that y equals 0 horizontal asymptote, but now we're going towards positive infinity instead of negative infinity. Okay. Okay, so what we're going to do now is we're going to graph the function f of x equals 2 raised to the x minus 2. But before that, we want to talk about how we can obtain that graph from f of x equals 2 raised to the x. And then we're going to check using our graphing calculator. Okay, so normally when we are taking a value directly from or giving directly to the x, what we wind up with is a horizontal translation. Okay, so since we're taking away from the value of x, we should be moving to the right 2 units. So that's our assumption, and we know this because we've done so much work with translations that we know if we're taking directly from that x, we move to the right. If we're giving 2, we move to the left. Okay. Now, if it was taken from the entire function itself, that would be different. That would be a vertical translation. Okay. So I want to double check and make sure that I'm right. We are going to skip the graphing by hand because we've done so much of this. So what we're going to do is we're actually just going to check this on our graphing calculator and see if we're right. We're going to start by graphing the parent function and then graph the function itself and see if we have indeed moved 2 units to the right. So we're going to enter a graph page, and I'm going to graph 2 raised to the x, and here's our original function. Now if I'm correct, what should happen when I graph 2 raised to the x minus 2 is I should shift my entire function 2 units to the right. So Control G brings back up my function bar, 2 raised to the x minus 2, and my function has indeed shifted 2 units to the right. Okay, 2 units to the right. So my point that would normally be 0, 1 is now 2, 1. So my x values increase by a value of 2. Okay. So let's take a look at another one of these. Now I've got 2 raised to the x minus 4. So again, we talked about this a little bit before. This time we're taking away from f of x. We're taking away from the whole function. Okay? So this should be a vertical translation. All right, vertical translation. Whoops. And we are going to be using moving 4 units down. So this is my thought. So we're going to check to see if we're correct. But given that we've done so much work with these translations, if I'm subtracting from the entire function, not just the x, okay, we should be having a vertical translation. So 2 to the x is my parent function. And we've got 2 to the x minus 4. Now, if I'm correct, it's going to shift down 4 units, which it did. 1, 2, 3, 4 units down. Okay. So now the point 0, 1 has become 0, negative 3. It changes the y value. Okay. And remember with these, our original has that y, horizontal asymptote at y equals 0. It also takes and it shifts that asymptote. So now the asymptote for this function becomes y equals negative 4. Okay. It didn't change the asymptote for my last function. It only changes it if there's a vertical translation, not a horizontal. So let's take a look at one more of these. Okay, so we've got 2 to the x is my parent function. And I've got 5 minus 0.5 raised to the x. So if you notice, I'm having a couple things change here. My base has changed. And I'm doing something to the entire function. So I believe there's going to be a vertical translation. And then this is going to have some effects too. I've got a negative in front of my base. So that means a reflection, oops, in the x-axis. And it's going to have a different direction. We talked about when we had 2 that became 1/2, the original function changed. It went from one to the other, one direction to the other. Okay, so that's the changes we're going to see. So we've got 2 raised to the x is my parent function. Notice horizontal asymptote at y equals 0. And we have 5 minus 0.5 raised to the x. So I'm assuming that we're going to have a reflection in the x-axis. Instead of increasing as x approaches 0, I'm going to be decreasing. And we're going to be translated as well. Oops. Okay, so I have shifted up 5 units. That's where that 5 is coming from. So, and I have reflected over my x, and I'm now going in the opposite direction. Okay. So my original, if I look at this before the translation, which may make it a little bit easier to see. Okay. Let's take this. Let's say I get rid of this piece here. All right. Notice that it's been reflected. But not only has it been reflected, I've changed this base. So let's take this one step at a time. Let's say it's negative 2x. Now we've got the reflection in the x-axis. If I now take this and change it to 0.5, okay, we reflect over the y-axis. So reflect in the x, reflect in the y, and now we're going to add on that 5. Okay, now we're going to add on that 5 and shift up 5 units. So what we did was we reflected, we had a reflection in the x, and then a reflection in the y. This does not want to work very well for me here. And then we shifted up 5 units. Okay, so there's a lot going on with this function. Okay. So I'm actually going to stop here, and we'll pick up with applications in the next video.